All right? Number 2. Same club. How many committees of 5 can they form? With 3 men and 2 women. How many committees of 5 can they form? 3 men, 2 women. So the question again we always ask, combination or blanks? Which one is it? Is this one blanks? Still committees, isn't it? It's still a combination, yeah. On committees, the order doesn't matter, so we're still... on committees, the order never matters. So ABC is the same committee as CBA. Committees are always combination. So it's still a combination, yes. However, how am I going to get the 3 men and the 2 women specified? Well, let's write that here. 3 men and 2 women. We're going to split it up, yes. We're going to do 2 combinations here. I'm going to do a combination for the men, and then I'm going to do a combination for the women. Because that's how I'm going to specify it out. So I'm going to do 2 combinations. All right, let's do the men ones first. Combination for 3 men. How many? So the first number on the C is how many there are to choose from. How many do I have to choose from here? I'm choosing from the men. 13. Well, yeah, I'm choosing 3 men, but I have 13 total to choose from, right? Yes. And I'm going to choose how many of them at a time? 3. The 3 goes here. Okay? How many we have to choose from? How many we're choosing at a time? Got to get that order in your head there. All right, what about the women? I want to choose 2 women, but in my combination, what's the first number? How many I have to choose from? How many women do I have to choose from? 17. I've got 17. 17 women. I want to choose 2 women. So 17, 2. So let's do combination 13, 3. It's 286. Combination 17, 2. 136. I'll get those numbers. That gives us 2 numbers. What do we do with it? Well, see that little word and? We talked about and in different places, but in counting, and typically means multiply. And means multiply. See the word and? Think multiply. So I'll multiply my 286 by 136. 38,896. Okay? Question or concern?
Okay, now to get the difference of them two, when you start out the original problem, you're going to just put it in 1. So if you add on to the original problem, then you need to divide it in 2.
Yeah, there's 2 groups specified. You'll need a combination for each one, or a part for each one. Yes.
But if number 2 was the original question, we wouldn't be doing that.
Yeah, if this question had just said how many committees of 5, we just have 1 combination. But because it specified how many men and how many women, we had to do 2 combinations. All right? Let's do a couple more. Number 3 on this, same club. How many ways could they elect a president Vice President, and Secretary. How many ways could they elect? President, Vice President, Secretary. Is this a combination, or is this blanks? Again, I told you, need to ask that always, because sometimes it won't be a combination. Sometimes it will be blanks. And it all boils down to, does order matter? ABC, is that the same as CBA? Well, in this case, President, Vice President, Secretary. President, are these the same? Not the same. Order matters. Order matters here. So it's not a combination, is it? Combination, the order doesn't matter. What does that mean? Blanks. President, Vice President, Secretary. That's all you got to think about. It's not a combination, then use the blanks. Not the blanks, use a combination. Okay. All right, so if I use the blanks, how many ways could I choose the president? We got 13 men, 17 women. Any of those could be president, right? There's no specification which is president, which is vice. 30 ways. 30 ways. What about this vice president? Well, I can't use the same president, so 29. And then I have to go 28, multiply those together. See? $24,360. Now, you know something else? We could have used what else here? Permutation, right? Because this is a partial countdown product. I didn't, but I could have used permutation. You don't have to use permutations, but sometimes you can use permutations. But this I could have done permutation 30, 3. Could have done that. That would give us that same number. Okay? All right. Everybody okay with that? All right. How many, we'll do some hands and cards. How many 5-card hands are possible using a standard deck? By standard deck, no jokers, just the cards. All right. And may not be that familiar with cards, but let's just go through a standard deck. In a standard deck, you've got 4 suits. Hearts, diamonds, spades, and clubs. Hearts and diamonds are red, spades and clubs black. Each suit has 13 cards. So there's 13 hearts, 13 diamonds, 13 spades, 13 clubs. There's an ace, and then there's a 2 through 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's a jack, queen, and king of each suit. So there's a jack of hearts, jack of diamonds, jack of spades, jack of clubs. Each one of these cards is in each of those suits. So that makes how many cards? 13 cards in each, 4 suits. 13 times 4, 52 cards in a deck. With me? All right, now, one other little note. The jack, king, and queen, those are considered face cards. And there's a picture in the book. It's the jack, queen, and king have faces on them, usually. So that's hence their name, face cards, but we'll specify those sometimes. Okay, so that's 13 cards. So back to our question. How many 5-card hands are possible? Well, again, our first question is always, is it a combination or is it blanks? And it's a combination if the order doesn't matter. Well, if I have ace, 2, 3, 4, 5, and then I have the 5, 4, 3, 2 ace, and let's say it's hearts. Is that a different hand? Same hand. Doesn't matter the order. Order doesn't matter on hands of cards. So what does that tell me? It's a combination. Order doesn't matter on hands of cards, so it's a combination. It is a combination just as committees are. Hands of cards will always be combinations. All right, so it's a combination. Now, what's my numbers? What's the first number? How many cards are there to choose from? 52. How many do I want at a time? 5. Combination, 52, 5. That's going to be 2,598,960. Did you get that? Okay. Let's do another 5-card. How many 5-card hands have only face cards? I said we'll sometimes specify red cards, black cards, face cards, even cards, whatever. All right. But in this case, how many 5-card hands only have face cards? Again, we're talking about hands of cards, so we're using combination or blanks. Combinations, yeah. Hands are always combinations. The order doesn't matter. I only want face cards, though. So doesn't that change this number? I can't put the 52 very well there because not all 52 cards are face cards. How many face cards are there? Well, there's a jack, queen, and king in each suit. Jack, queen, and king here, 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 and here. How many does that give you? 12 face cards, right? All together. The jack. You got a jack, queen, and king of hearts, a jack, queen, and king of diamonds, a jack, king, and queen of spades, and a jack, king, and queen of clubs. That's 12. All right, so what's my combinations then? How many are there to choose from? 12. I want only face cards, so I'm only going to pick 12 from 12. How many do I want? 5. 12, choose 5. Or combination 12, 5. That's 792. Okay?